Hello everyone. Welcome to my channel Chai Commerce Entertainment. In this video, I'd like to discuss what exactly is pointers and the structures in C programming or even in C++. Why are they used and what exactly the uses of those. So this is purely for the beginner course. If you're really curious to understand why are they used, how are they used, yes, you have clicked the right video. So let's get started. Okay, let's try to understand what exactly are the pointers. So pointers are the variable that stores the address of the another variable. As a beginner, you'll be having a follow-up question. Why exactly should I care about the address of other variable? Why not just use the variable itself? To understand that, you need to understand how exactly the computer sees the variable. Now, let me actually declare a simple integer variable a equal to 25. Now, for human beings, a is equals to 25. But how does the computer see? So, computer see, okay, a could be somewhere in the RAM, and in that RAM, it will be having in some memory address. Let's call that memory address E2000 for an example. Inside the memory address 25. So basically, this is how the computer sees, saying that this A is nothing but address 2000 and 25 is actually residing inside the 2000. And I have discussed in detail in one of my previous video how the variables are stored and how they are behaved. This particular video, I encourage you to go and watch this video. The link will be provided in the description box. Anyway, let's get back to this topic. So I was telling this particular variable will be stored in this particular address. Now I want to as a programmer, I want to know where which address is this A is storing in. So in that scenario, I will actually get pointer variable. This is how we declare int star ptr equal to ampersand A. So when you try to print ptr, so it will print the address that is 2000 in this particular case. Basically, C programming or a C++ programming provides one of the strongest feature to access the memory address. And guys, you might also ask another follow-up question saying that, hey, can I actually, instead of actually worrying about the variables, so I'll declare the pointer variable and can I directly assign 2000 like this as an address? Yes, you can totally you can assign it. But however, compiler will throw an error when you try to assign the value like. So in that case, you need to do something called as typecast to pointer. So when you typecast to pointer, so this initially by default, this will be stored as a integer type. When you typecast to pointer, this will be treated as address. So typecasting is done in this way. Anyway, so yeah, in basically in embedded systems, so if you really want to access some hardware registers, you know the address of the hardware registers. This is how you generally define. I'll be discussing in detail about all these things in the future videos, and I'll be discussing what exactly the registers also. So I mean, let me actually give you the brief what exactly the registers are. So registers are also special kind of memory, just like RAM, but when you actually when you write value, let's say to this register, let's say 26 or 30, whatever the value. So whatever the value that you write to the registers, the behavior of the system actually alters. It will alter the behavior of the system. Whereas in the RAM, let's assume you alter the variable value of 25, let's say 26, the behavior of system won't get altered here. So that's the difference between RAM and the register. The only similarity is register are also memory address, but it's completely a memory map in a different locations other than RAM. I'll be discussing in depth about these concepts in my further videos. Like what are those registers, how the address of the registers are assigned to the pointers in this particular example in depth. So you'll understand mostly in that. But now, as a let's stick on to understanding the pointers. So pointers is one of the powerful features provided by C programming and of course C++ as well to directly access the system registers address. It's really powerful features. Of course, there are a lot of disadvantage also, advantage also. You don't have to worry about the disadvantage and advantage. Now let's primarily focus on pointers. This until here, I hope things are clear now. Now, before even continuing to the pointers, let me actually explain you something called as the two important concepts called as pass by value and pass by reference. So, what is pass by value and what is pass by reference? So, to understand this concept, I will actually write a simple program. Let me open, as usual, my favorite online C compiler. Now, what I'll do is I declare two different variables int a equals to 11, int a equal to 11, int b equal to 12. Now, I'll create a function. I'll pass a and b to this function. And inside this function, what I'll do is I'll increment the value of the a and b. So I will call it as in x and y. So it doesn't matter, guys. You can call anything here. Now, I will increment x here and I will increment y here. Okay. And then I'll try to print the value of A and B. A equal to percentage D, B equal to percentage D, A, B. So what is your expectations? So you'll see I'll pass A and B to this and I'll increment X and Y to this. And you're expecting 11, like 11, when 11 is incremented, it is 12 and 13. So your expectation is 12 and 13, right? Let's try to understand what exactly is happening. It's like, oh, it's just A and B only. Oh, this is fishy. So I'm incrementing the values of A and B here. In the form of X and Y, it doesn't matter. But yeah, so A will be equal to X, B will be equal to Y. Regardless, it should increment, right? Let's try to understand in memory what exactly it is happening. Let's get back to it. So, in my previous video, I have introduced the concept of stack frame as well, how stack frame behaves. Please, I would encourage you to watch this video before you even jumping to the current video. So now what I'm doing is like I explained in the previous video. So main function will be having a stack frame. And where are the stack frames are there? So stack frames are residing in the RAM only, like I explained in the previous video. So this is a stack frame of a main function. So here I'm having int A and int B. Let this address be like 2000 and 2004. So these are the address. So what I'm doing inside the address, I'm actually calling a function by passing a and b. So what are the values of a and b? A was 11, b was 12. So when I call the function, if when I call this function, the stack frame of this function will be created. So when the stack frame of the function is created, so here I am passing in the form of x and y. A and b is converted into form of x and y. And so let's assume this x is in address 3000 and the x is in 11. Now what I'm doing, I'm incrementing 11 here. So 11 will be 12. And let's assume y will be, so just to make it clear, this will be address of the x and this will be address of the y. So y will be 3004. Let's assume this. And now y was actually 12. Now I incremented to 30. So basically, both of this. Now when I exit this function, so the contents of the stack frame are destroyed or deallocated. Now whatever the value that was updated value of 12 and 13, even they are gone. When I try to print, A and B. So it will be printing the contents of address 2000 and 2004. That is 11 and 12. So that's a reason you guys are seeing old value despite of updating here. So okay, what can I do now? Can I actually try sending the address itself instead of value? Okay, let me try that luck. Can I do it or not? So let me go back to the code. So now instead of passing the value, let me try sending the address itself. Now, since I'm actually sending the address here, like I said, it should become a pointer variables. X and Y should become a pointer variables. And you cannot leave it like this. When you actually increment X and Y like this, it will increment the value of 2000 and 2004. I don't want that. I want to increment the value that is residing in 2000 and 2004 address. So how do I do that? It's simple. You need to dereference it. So the way to dereference is this way. So use the star, asterisk, star, whatever people call it. Some people call it as asterisk, some people call it as star. Let's run and see if we are seeing the expected value or not. We are seeing 12 and 13 now. Cool. So now what exactly is happening? Let's get back to the stack frame, guys. As usual, let's go to the main function stack frame. So this is the stack frame of the main function. A will be x 2000, that is equals to 11. B will be x 2004, that is equals to 12. Now, inside the function, to the function, I'm passing the address of A and B. Now, obviously, the stack frame of the function will be created. They will accept the value in the form of pointers or the address. So basically, instead of the value itself, we have the address. And what are the contents inside the address? The content was 11 and 12. So what am I doing here? I'm incrementing 11 and incrementing the content inside the address. So that is, I'm incrementing 11 to 12, 12 to 13, and again, it will be stored inside this address only, 2000 and 2004. And when it exits, all of these things will contents stacks content stack frame of the func will be deallocated, and whatever the contents that is present inside the address 2000 and 2004 will be printed. So what are the contents of the 2000 and 2004? That is 12 and 13. So 12 and 13 is printed. Now that is what you guys are seeing now. So basically, the first method we call it as pass by value. So why? Because we are actually passing the value itself to the other function. Second one is called pass by reference. Here we are passing the address of the variables to the function. Okay, why do I even need to care about pass by value or pass by reference, right? That's a question, right? And you also have the question like, under what circumstances do I need to care about pass by value or pass by reference? So the circumstances would be, let's say you will introduce in C, say it's 13. Now you don't want this int C to be altered inside a function, inside this function fun. So instead, what you want is this particular value, whatever you give, 1 second, guys. So if you don't want this, let's say this, I want these two functions to alter. I want, sorry, not functions, the variables. I want these two variables to be altered. And this one, just say I don't want to alter. In that circumstances, you can, if you don't want this value to be altered, you can actually do pass by value. So you call it as Z. So XYZ. And now, so basically I want, let's say I'll update the X value, uh, star Y value to be star X plus Z. So in this case scenario, you're not altering the Z value. You're just using Z or whatever the C to compute the value of Y. Now see, sorry. Let me run the code now. So basically, I'll increment the value of x, that is 12. X is what? 11, 12. Here it was 11, 12. The value become 12. And here it is 12 plus 30. The result is 20. So basically, you're computing the value of C to alter the value of B. That's it. So basically, you're computing the value of B using C. So C you don't have to alter, you need to alter A. Sorry, you need to alter B. In that scenario, you can use pass by value for this, pass by reference for this. So till now, you guys got an idea like when to use pass by value and pass by reference. And there is also another scenario where you can actually use pass by reference advantage. Let's assume we have two different files. I'll call it as file1.c and file2.c. So let's assume like file like in the file2.c there is a global variable. So into global, just an example as a global variable equal to 20. So I need to get this global variable inside the file one. So how do I get? What I'll do is I'll actually declare let me actually write a main function simply, just for simplicity. I'll say, hey, I want a global variable that is present inside here. So what I'll do, create a function. So let's say I'll call it as I want a variable. I'll create a function called get global and I'll pass address of variable and I'll do print of percentage d var. Now here in this file, I'll declare the same function get global. The function do not void. I don't want this function to return anything. Pointer, since I'm passing the address here, so obviously it should become a pointer, right? With the pointer x. So star x equal to global. So if you want to fetch the content from a different file that is not visible in the current file, in that case, you can also use pass by value. Sorry, pass by reference. So far, these are the usage of pass by value and pass by reference. So this is pointers another advantage. Okay. Till now, you guys learned about what is pointer and what are the uses of it. And in addition to that, you learned about the concept of pass by reference and pass by value. Now, I'm actually going to continue with another pointer concept called pointer arithmetic. When you try to increment the pointer value or the pointer address, by how many bytes will it increment? So for that, I have drawn a table here. So based on the type of the pointer, when you increment by one, what is the final value? So it is actually this one. The first one is integer pointer. So the integer is of 4 bytes. So when you increment by one, the final address will be 2004. The same goes to uint32 too. Uint32 is also 4 bytes. So when you increment the pointer by 1, it will increment by 4 bytes here as well. Now coming to pointer uint16t, 16t means 16 bit needs two bytes, right? So when you increment by 1, this will increment by 2. Same goes, and this one is uint8t. Uint8t means 1 byte. So when you increment by 1, so this is the one that actually increment by 1. So plus 1 will result in plus 1 for uint8t. The long, when you increment by 1, so there are two scenarios for long. So for 32-bit system, it will increment by 4 32-bit systems. And for in case of 64-bit systems, it will increment by 8 bytes. So these final address are fixed regardless of the system. So only the long is impacted. And character is also 1 byte. So when you increment 1 byte, it will increment by one for the character pointer. And the float is 8 bytes. So regardless of the system, it will increment by 8 bytes. So basically, based on the data type, based on the type, so corresponding number of bytes will increment when you do a pointer arithmetic by one. Now, what about the void pointer? So let's assume the void pointer has same address 2000 when you try to increment. So what would be the result? So compiler won't allow. You'll get a compiler error. Why? Because void pointer type is not defined. It's not known. Whereas these kind of things, the sizes are known. So that's the reason pointer operations, a pointer arithmetic are permissible here. Here, pointer arithmetic is not permissible. And talking about the size of the word pointer, it will be 4 bytes in 32-bit system and 8 bytes in 64-bit systems. This is all about pointer arithmetic. Till now, you learned about different data types like integer data type, character data type, float data type, unsigned 16, unsigned 8, unsigned 32, whatever the data type. Now, let me actually create a small exercise. So, the exercise would be I have a numerous number of employees and I need to store their database. So, what could be those? What could be their data? The data would be like employee ID. So, that employee ID would be of integer type, the salary of an employee, age of an employee, and the name of an employee. So name, I'll just keep it as character array of 20. Okay. So these are all different data types int, float, in character. So this is a data of a single employee. What if my organization has hundreds and hundreds of employees? So will you create hundreds of copies for each employee like this? Will you have the hundreds of copies for each employees? Obviously no. So there should be a mechanism wherein you need to create just using the single data type without duplicating it. You need to have the details of those 100 employees. What could be the mechanism or what could be the feature that we are expecting from a C programming? That feature, C programming provides that. So, structure. So, how do we do it in the structure? The syntax for the structure is this one, struct. I'll give the name of a structure, let's say employee, and then open and close bracket. I'll move all of this inside them. So this itself, struct employee itself has become a custom data type. So the concept of structure is to build a custom data type using the existing data types. Now, how do we even create the 100 copies? Simple. Get the data type, create an object or the variable of this data type. The name of the variable would be an employee, and I'll make it as array. So if there are 100 employees, I can go ahead and fill 100 arrays. Just an example. So this is an example for structure, how it can be used. However, uh, this is actually very simpler explanation. So if you at the moment when I start writing the drivers in my further videos, you will have solid grips of understanding what structure is. Anyway, let me continue. Now I need to fill in all the details. The simple way to dereference array is so array of 0. And if I want to fill in the employee ID, dot employee ID equal to 10. Just an example. Similarly, dot salary equal to, let's say that person is earning $3,000 and I'm filling an age of that employee. Age, let's say 20 years. And the name. What is the name of that employee? Is this particular employee? So name is a string, right? So I'll use a string copy, not a strncp one. So this is all you filled. Now, similarly, if you want to fill in the second employee detail, do the index one, 11, let's say that percentage actually. earning 60,000 and that person age is around 40 and the person name is Dan, something like that. And so on, you go on filling the details of employee. Of course, you can't, you guys won't individually copy paste like this. In real life, you guys will actually write a for loop and keep on filling the details of an employee like this. Regardless, I didn't want to go in-depth details. I just want to give you the brief introduction about the structure. So that is what I'm doing now. Okay, so this is one aspect, a simple introduction about the structure. So let's remove it. Let me actually, for now, I'll reduce remove the types inside the structure. Now, if, for example, if I get the size of integer, it can be 4 bytes. It can, character can be 1 byte, right? Similarly, what is the size of a structure, right? That's a question people generally ask. So let's see. So the size of a structure, you think it's a 4 plus 4 plus 1. 4 plus 4 plus 1. 9 bytes. That's what you guys think, right? Let's see if that is true or not. So you will use the size of struct employee data type. So it should be, this one should be 4 and this one should be 4 as well. Why? Because integer type and this one is 1 byte. Let's see if that is true or not. Oh, why are we seeing 12 here? Okay. So this is something interesting that I would like to teach you guys. What is that interesting concept all about? Now, uh, I'll draw a memory layout. So it's just a memory layout. So employee ID, employee ID is of integer type. So it should be 4 bytes, right? One, two, 3, 4. So 1, 2, 3, 4. 4 bytes, right? And the age is also integer type. So it should be 4 bytes only. And this character is of 1 byte. So I'll just draw one box here. So character is of 1 byte. So this is integer byte, character byte, right? So basically I expect 9 bytes. Apparently the result is 4 bytes. So what is the beauty about structure is it will fill up these empty spots and try to match with the above data types so that extra 3 bytes are padded. So because of which 4, 4, 4 and this become 12 bytes. So this concept is called structure padding. So generally structure padding is a concept where structure the data member variables inside a structure that tend to align. So why generally structure does this is so basically whenever CPU wants to access some address, those addresses needs to be aligned. So what does align mean? In this case, it is 12 bytes means it's a 4 bytes aligned, which means it should be multiple of 4. So 12 is actually a multiple of 4. So CPU CPU wants aligned address. So if it is not aligned address, so generally there is a probability of going into the wrong address. So whenever it does a branch instruction, I'll explain you what exactly is a branch instruction. So whenever you call a function internally, assembly instruction will invoke that is called branch instruction. There is a chances that branch instruction will go into wrong place. So that is handling of alignment. Yeah. So structure will try to prevent that. So they will try to pad it and try to prevent it. There is another beautiful thing as well. I'll change this to character. So what could be the type? Let's see. It's still 12. Why? Because whatever, so now since it is like initially, since I changed this to character, so this could be only 1 byte, right? So, but still there is a major 4 bytes here. So still they try to pad up and pad down. So regardless, they want to maintain the alignment of whatever the longest data type, the member has. So they try to align with respect to the longest data type. In this case, the longest data type value is integer. So character, both of these character, they try to align the structure padded to with respect to this. I hope you guys understood till now whatever I explained. Now, how would structure pointer behave when I try to do the pointer arithmetic for the uh, structures types? So let me declare a structure variable. I'll just say an employee. It's not a pointer though. The pointer as a definition, it should point to the address of another variable, right? So I will say employee pointer equal to address of an employee, trying to respect the definition of a pointer. So regardless of whatever the data type it is, they should respect the pointer should point to address of another variable. Okay. Now I'll try to increment the employee pointer plus plus, similar to what I did here, like PTR1 plus plus, PTR2 plus plus, PTR3 plus plus. So before that, I will keep a track of starting address and end address. Address equal to employee pointer, and I'll typecast to you 32T, and I'll increment here. And next, the same thing, I'll get the final result. So this is end pointer. So start pointer and end pointer. And I'll try to print the difference between start and end. Let's see how many bytes did it increment. Percentage D. So end pointer minus start pointer. So let's try to run. Oh, you in 32T. Okay. We have to include std int.h. So unsigned 32 and uint 8t, uint 16t, uint 32t, all of these are defined here or declared here in this header. Okay, I'm seeing 12, but why am I seeing this warning? Okay, instead of uint 32, I'll use uint ptr. I don't want to see that warning. So anyway, like the employee pointer is actually pointer address, right? I'm just typecasting to the U in PTR instead of U in territory. So yeah, doesn't matter. Yeah, the now warning went off, and you're seeing the value 12. So so basically, if you increment, it is incrementing by the size of a structure. That's it. That's all the video for this, guys. In my further course, I won't be teaching much about C. Basically, this is purely the crash course on C. I didn't want to go in depth about C concepts. I was just rushing. So in my upcoming video, I'll start writing the drivers slowly. I'll start doing deep diving into C. Basically, you'll be seeing actual embedded systems. Here, I just wanted to give the intro of pointers, how they behave, and structure how they behave when they are pointers. It's just a crash course on C. Of course, I know I rushed a lot of concepts. If you have any confusions or doubts, you can ask me in comment section. I'll respond to you. So my aim is not to teach you C programming. My aim was teach you embedded systems. So yeah, with this, I am ending this video. If you like this video, please click a like button. You can also dislike if you didn't like my teaching. Of course, I rest a lot of the concepts here. Regardless, in my upcoming video, I will be very slow and you guys will be enjoying all the concepts, whatever I learn. So yeah, thanks for watching.